Welcome to the lecture on problem solving based on compounding frequency and effective interest. In this lecture, we will also solve problems based on gradient series. Let us see the first problem. This problem is related to the gradient series. So, a person is planning to save rupees 5,000 from his income during this year and can increase this amount by rupees 1,000 for each of the following 9 years. So, basically the time span is 10 years. First year he is saving 5,000 and from the next year onwards he is increasing this saving every year by 1,000 rupees. So, G is 1,000, this is linear gradient amount. Interest rate is 8% compounded annually. What equal annual series beginning at the end of year 1 would produce the same accumulation at the end of year 10 as would be realized from the gradient series. So, basically this is a problem which talks about the cash flow series like this. You have a 10-year time starting from 0, 1, 2, 3 and then it will go year 9 and year 10. Now, the person is basically saving 5,000 during this year. So, in the first year he is saving 5,000. Year end convention is followed. Second year he will save 1,000 more. So, it will be 6,000. Third year 1,000 furthermore 7,000 and this will go on like this. Accumulation can be realized by annually depositing certain amount. So, this should be equal to a cash flow series which will go like this. What should be basically this amount A. So, in this problem what we will do is we have to calculate. Now, as we have already discussed, in this problem you have two components. One is fixed component every year. So, fixed amount of deposit every year is 5,000 and gradient series G value of 1,000. Now, first of all, for this gradient series, we should calculate the annual equivalent, annually deposited amount which will be equal to that paid by gradient series. This amount obtained has to be added to rupees 5,000. This will give basically us the final answer. The annual equivalent value for this gradient series gradient series we have the formula, and from this we can calculate this annual equivalent value, and that will be nothing but G times 1 by I minus N I by 1 plus I raised to the power n minus 1. And if we calculate this value, this factor value, this comes out to be 3.8713, and G is 1000. So, this value comes as 3.871. So, it comes as 3871. So, your final A, this A will be nothing but the fixed component of 5000 plus 3871. So, your A comes as 5000 plus 3871, that is 8871 rupees. This is the answer. So, what we see is what amount you will deposit by depositing rupees 5000 during the first year end, and further increasing this amount every year by rupees 1000. The same amount can be depositing if you deposit every year end an amount of rupees 8871. So, these type of problems can be solved by finding the component of the annual equivalent value using this formula first, and either subtracting or adding to the fixed component. So, this is the final answer. Let us go to the next problem. The next problem is related to the geometric gradient series factors. We have basically discussed two types of gradient series factors. One is the uniform gradient series, another is geometric gradient series. In the geometric gradient series, the gradient is not a constant amount, but it is increasing as a percentage. What is there in this question? Income from a company is estimated to increase by 7% per year from a first year base of rupees 720,000. So, the income is increasing every year 7% from this base. It means in this problem it is given the G is 7%, that is 0.07. This is the percentage increase with respect to the first deposit. F1, that is first deposit or first income, it is given as rupees 720,000. Then what will be the value of the present worth of 10 years of such income at an interest rate of 15% compounded annually? So, what you have been given is annual interest rate is 15%. So, let us see the cash flow diagram. The cash flow diagram tells that in the first year it is 720,000, and it is growing further up to 10 years. So, basically it has to increase like this. Now, we have to find basically the value of the present worth. So, what is the value here which is whose value is same as what you would deposit in this type of cash flow. So, we have been given I, F1 and G. So, we will use the formula for gradient series factors to calculate the value of present worth, and we know in this first of all we have to calculate G prime. So, G prime is nothing but 1 plus I upon 1 plus G minus 1. So, what you see is 1.15 upon 1.07 minus 1, because I is 15% and G is 7%. So, because we have seen the formula is 1 by 1 plus G prime is 1 plus G upon 1 plus I. This is the formula. So, G prime can be calculated as 1 plus I upon 1 plus G minus 1, and this comes out to be 0.0748. Now, once we calculated the G prime, the present worth value is given by the formula F1 upon 1 plus G into 1 plus G prime to the power n minus 1 by G prime into 1 plus G prime to the power n, that is nothing but P by A G prime n. This is nothing but the factor P by A G prime n. This we have already derived while studying the geometric gradient series factor. Now, if in this G prime we know that is 0.0748 and this factor comes out to be 6.8704. So, what we see is this F1 is 720,000 divided by 1 plus G, G is 0.07, so 1.07 multiplied by this factor comes out to be 6.8704. And that is why the value of this sum comes out to be 4623072. So, this is the amount which is the present worth value of such a geometric gradient series factor. So, P is 4623072. This is the required answer. So, in such cases what we have seen is, first of all, depending upon the value of I and G, you have to calculate G prime. Once you get G prime, you get the factoral value of P by A G prime n. Once you calculate this, this will be multiplied with F1 upon 1 plus G, and that gives you basically the present worth of such geometric series. Next will be a problem based on the effective interest. Already we have solved few problems. Now, in this case we are required to calculate the effective interest rate. So, in this question, suppose that you make quarterly deposits in a savings account which earns 9% interest compounded monthly. Compute the effective interest rate per quarter. Now, how much will be the answer to this question? So, what you see is your R is 9%, compounded monthly, and you have to find the effective interest rate per quarter. It means L is in terms of years, it is 1 by 4 years. Per quarter you have to calculate. So, it means you have to calculate for 3 months. So, L becomes 1 by 4 years. M, it is compounded monthly. So, compounding period in terms of years is, and reciprocal to that is M. So, M is reciprocal of this compounding period in years, that is 1 by 12, that is 12. So, once you get that, you can use the formula of effective interest rate calculation. So, effective interest rate will be 1 plus R by M raised to the power L into M minus 1, and that will be nothing but 1 plus 0.09 divided by 12 raised to the power L into M, that is 1 by 4 into 12, that is 3 minus 1. So, 1 plus 0.0075 raised to the power 3 minus 1, and that comes out to be 0.0227. So, this is coming out to be 2.27%. So, what we see is this is a 9% interest per quarter. Had it been the quarterly compounding, in that case per quarter the effective interest rate would have been 9 by 4, that is 2.25%, but the compounding is done monthly. So, basically due to that the effective interest rate for the 3 months becomes slightly more than 2.25%, and what you get is 2.27%. So, this is how you can calculate the effective interest rate for any time interval. Now, we will see the comparison of the interest rates when the compounding frequency is changed. So, this problem talks about the annual interest rate, effective annual interest rate, how it changes when the number of periods per year or compounding frequency changes. Now, let us see when the compounding frequency is annually, that is it is done only once. In that case the effective interest rate per period, because it is already a nominal interest rate of 12%. So, your effective interest rate per period is 12%, and what the annual interest rate also is 12. Now, when we go for semi-annual basis compounding, now in that case as we do the semi-annual compounding, we are doing the compounding 2 times. So, number of periods per year is 2, and basically the effective interest rate is 12 by 2, 6%, because 6% interest is levied upon every 6 months. So, for a period of 6 months the effective interest rate is 6%, but if we try to calculate the effective interest rate on for the year, in that case it comes out to be 12.36. Now, how it comes? So, in this case as we are doing the semi annual basis, you have number of periods per year as 2, and L is basically 1. L is basically 1 year, compounding is done twice. So, period is 1/2 year and the reciprocal of 1/2 is 2. So, effective interest rate comes out to be 1 plus, since R is given as 12%. So, 0.12 by 2 raised to the power L into M, that is 2 minus 1. So, 1.06 raised to the power 2 minus 1, it is 1.1236 minus 1. So, 0.1236. So, you can write it as 12.36%. So, this is how we calculate when it is semi-annually interest is levied upon or interest is calculated on semi-annual basis. Your effective interest rate for the year comes to 12.36%. You go further, if you go for quarterly, in that case L anyway is 1 year. Once you go for quarterly compounding, in that case M is reciprocal of 1/4 years, that is for 3 months. So, 1/4 years, that comes as 4. So, in this case I will be calculated as 1 plus 0.12 divided by M, M is 4 raised to the power L into M, that is 1 into 4 is 4 minus 1. So, 1.03 raised to the power 4 minus 1, and that gives you the result of 12.55%. So, effective interest rate basically for the year changes from 12 to 12.36 when it is done semi-annually and to 12.55% when it is done quarterly. Further, if you go for monthly, in the case of monthly calculation, L being 1 year, M now becomes reciprocal of 1/12 years. So, it becomes 12. So, effective interest rate for 1 year period becomes 1 plus 0.12 by 12 raised to the power 12 minus 1, and this if you calculate, it will come out as 12.68%. In this way, if you go to calculate on weekly basis, L being 1, M becomes 1/52, that is 52. So, I will be 1 plus 0.12 by 52 raised to the power 52 minus 1, and this comes out to be 12.73%. Similarly, if you go for daily, in that case your L is 1, M is 1/365 years. So, it is 365, and in that case I becomes 1 plus 0.12 by 365 raised to the power 365 minus 1, and this comes out to be 12.73%. 747%, sorry. Now, if you go for continuous basis, in that case we know that it is, since we are doing on annual basis, annual effective interest rate, we know that the formula is I equal to e raised to the power r minus 1. So, exponential of 0.12 minus 1, and this comes out to be 12.749%. So, what we see, this we have shown how you can calculate the different value of effective interest rate and annually the effective interest rate, how it changes when the compounding frequency is changing. So, this we can practice. Next, there is a question which talks about again the use of gradient series factor, where basically a man is purchasing new automobile and he has to put aside some money in the bank so that he can pay the maintenance fee of the car every year end. For the first 5 years he has to pay 4,800 in the first year, and thereafter the cost will increase by rupees 1200 every year. So, how much should he deposit in the bank? So, basically this problem tells about the finding the present worth, finding the present amount for gradient series. We have already discussed how to calculate the value of the annual equivalent for the gradient series, that can be used further to find the present amount for this gradient series. You can treat this problem as an assignment problem. The answer to this question, you can have the help of some of the tables. A by G 55 is given as 1.9025 and P by A 55 you can have it as 4.3295, and the answer is 30665. So, treat this as the assignment problem and we can discuss it in the coming classes. Thanks.